So you learn how to use locks to implement synchronization. Now in Java, we have another tool for implementing synchronization, and that's the synchronized keyword. Using the synchronized keyword, we can achieve the same result, but without explicitly creating a lock object and locking and unlocking it. So our code looks simpler. Let me show you. First, I'm going to delete the code that we wrote in the last video. So delete and delete. We also don't need this lock object anymore. So if we run our program, now we should have a race condition. There you go. So to prevent this, we want to make sure that only one thread at a time can execute this piece of code. To do that, we wrap this inside a synchronized block, like this. Now here in parentheses, we should pass an object. This is what we call a monitor object. Every object in Java has a built-in lock. So Java is going to get the built-in lock from that object and use it under the hood. For example, we can pass this as a reference to the current object, but this is a bad practice. I will explain why in a second. First, let's run our program again and see if the synchronized keyword actually solved our problem or not. So run. There you go. The problem is fixed. But why is passing this a bad practice here? Well, let's add another field in this class, private integer total files. With this, we can keep track of how many files we have successfully downloaded so far. Now, we need a getter for this field. So let's create it real quick. Create getter for total files. You also need an increment method. I'm going to type that manually. So public void increment total files. And here we increment total files. Now, we want to make this new method thread safe as well, because it is possible that two download threads finish concurrently. So we don't want them to update the total files field at the same time. So we wrap this inside a synchronized block with this as the monitor object, like this. Now, with this implementation, if one thread is calling the increment total files method, another thread cannot call the increment total bytes method, because both these methods are using the same monitor object. So only one thread at a time can call into a synchronized method of this object. This is like having a single hotel room. Each monitor object represents a hotel room. So with this implementation, if one thread is updating the total bytes, another thread cannot update the total files field. That's going to cause a lot of overhead. The whole point of synchronization is to make sure that two threads cannot modify the same data at the same time. But here we're dealing with two different fields. So using the same monitor object reduces the throughput of this class. It can cause unnecessary waits. Now, in a simple application with a few threads, you may be able to get away with it, but in a larger application with more concurrency requirements, you should use dedicated monitor objects. Let me show you. So we add two new fields to this class, private object total bytes lock. We set it to a new object. And one more time, we create another field called total files lock. Note that these are just plain object instances. They're not lock objects, okay? Now, why object? It's just a common convention. Technically, we could use any type here, but it's more conventional to use the object class because we are not looking for any specific behaviors, okay? Now, in this method, instead of synchronizing on this, we're going to synchronize on total bytes lock. And in this other method, we're going to synchronize on total files lock. So two different monitor objects. Now, there's another way to use the synchronized keyword. Instead of using it as a block, we can declare this entire method as synchronized. So we type public synchronized void. And this is exactly equivalent to writing synchronized this. So this will wrap this entire method inside a synchronized block. Again, you should be cautious about this approach because this is going to synchronize on the current object. And as I told you earlier, this can cause a lot of unnecessary waits. So it's better to use the synchronized block with a dedicated monitor object. Now, all that aside, synchronization is bad. Your code runs sequentially and you lose concurrency. Also, you may cause deadlocks and all sorts of crazy bugs that are hard to reproduce and fix. So, as a best practice, don't use it in new code. I just included in this course in case you're maintaining an older code base that uses synchronization, so you understand what it is and how it works. Next, we're going to look at another solution as a lightweight and simpler alternative to synchronization.